In this, we're being asked to find in the first part how many inches our block is going to move up as our wheel rotates. Okay, so the big idea is that the amount that we move along the arc, that length is going to be the same as however much, our block moves up. So those are the same thing. So if we can find those, that's going to be S. Okay, so what we're really being asked is the arc length when our angle is rotated at an angle of 80 degrees, 50 minutes. Okay, so we're going to use the formula arc length is equal to the radius times the angle, but remember that the angle needs to be in radians. So since our angle is in degrees and minutes, first we're going to convert it to decimal degrees, and then we'll convert it to into radians. Okay, so to convert to decimal degrees, we take our degrees. Okay, and now we're going to convert that 50 minutes into degrees. We want to get rid of our degrees, or sorry, minutes. There's 60 minutes in 1 degree. Okay, so that gives us 80 degrees. This converted into 0.833 degrees. So we've got approximately 80.833 degrees. Okay, so that's our angle in degrees. But to go into this formula, we need radians. Okay, so here we go. Our angle, now we're going to convert to radians. Okay, so we've got 80.833 degrees. We want to get rid of degrees. That's the same thing as 1 pi radians. So our angle is now approximately, we've got 1.41 radians. Okay, so now this can go in for our angle. And the radius is 8.98. So our arc length is going to be the radius, so 8.98 times the angle in radians, which is 1.41. Okay, and then that is 12.66. That rounds up to 12.7. And our units there are in inches. Okay, good. So the big idea is we're going to use our formula, but just remember we need to have radians, and this was complicated because it was in degrees and minutes. So first we had to convert it to degrees, decimal degrees, and then we had to go to radians. So that was pretty complicated. Okay, in part B, we're being asked to figure out the angle. Let's see. It's going to be raised 7 inches, so that's our S. We need to know our radius is still the same thing. Okay, but we want to know our angle. All right, so here we go. We're going to take 7 is equal to 8.98 theta. We're going to divide both sides by 8.98. And I got approximately 0.77951, but remember that this is radians. So now this is in radians, and because this asked me to the nearest minute, okay, so now the first thing I'm going to do is I'm going to convert from radians to degrees. Okay, so here we go. We've got 0.77951 radians. Now I want to get rid of radians, so I'm multiplying by my well-chosen 1. Pi radians is the same thing as 180 degrees. So I'm going to multiply that, so here's my theta. Okay, so I've got 44.6626, and I'm supposed to convert this to nearest minute. Okay, so my 44 is good, That's going to be my degrees. Now, my 0.6626, that's in degrees, and I want to convert that to minutes. Okay, so I want to get rid of I want to get rid of degrees. And we've got 60 minutes is the same thing as 1 degree. So I'm multiplying that decimal part by a well-chosen 1. You know, it's my unit fraction there. What I want to get rid of is what I put on the bottom. So I can cancel my degrees. Okay, and I get 44 degrees, and that is about 39.756. So I'm going to round that up to 40 minutes. So it would be 44 degrees, 41. Oh, whoops. That is 40 minutes. And that is my theta. All right, hopefully that helps. These are complicated because you're doing a lot of conversions. Yeah, so there's a lot going on with that.